Okay, so I'm going to be explaining application problem number 2. And so, a small software company invests $16,000 to produce a software package that will sell for $55.95. Each unit can be produced for $35.45. So for part A, how many must be sold to break even? What we're going to do is we're going to take the value that it sells for, so $55.95. So we're going to do 55.95x minus what it's produced for, which is $35.45. And that's also x. And we're going to set that equal to $16,000 because that's our total. So 55.95 minus 35.45 is 20.5x, and it's still 16,000. And then x is approximately 780 units. So that's how we solve for the units. Okay, for part B, we need how many units must be sold to make a profit, to get a profit of $6,000. So what we're going to do is we're going to set it up. We're going to do 55.95x minus 1,600 plus 35.45x. And where we get this from is basically we need to take into account the $16,000 we invested plus the $35.45 we need to produce each unit. So that's where that comes from, and we're just going to set it all equal to 60,000. So after we simplify and solve for everything, x is equal to 3,800 units. And so that's how many units we need to make a profit of 60,000. Okay, the next problem we'll be solving is number 6. So 2 cheeseburgers and 1 small order of french fries from a fast food restaurant contain a total of 850 calories. 3 cheeseburgers and 2 small fries of french fries contain a total of 1,390 calories. Find the caloric content of each item. So we're going to start off by making cheeseburgers x and making fries y. So for the first equation, what we're going to do, so we have 2 cheeseburgers, so that's 2x, and 1 order of small fries, so that's y, plus y, and that is equal to 850 calories. We set that equal to 850. For the second equation, we have 3 cheeseburgers, so that's 3x, and 2 small orders of fries, so that's 2y, and that is equal to 1,390. So now what we're going to do, since we have the 2 equations and they have the same variables, we're going to set them equal to each other. So we do -3 and 2. And now our new equations are going to be -6x minus 3y is equal to -2,550. And for the second equation, we get 6x plus 4y is equal to 2,780. So these cancel out. So what we're left is y is equal to 230. And since y is our french fries, so we get fries. So we get fries are equal to 230 calories. So now we're going to plug the y back into the first equation since it's easier. So we get 2x plus 230 is equal to 850. And we get 2x is equal to 620. And so x is equal to 310. So the burgers contain 310 calories. Okay, so a problem I'll be explaining that I missed is a 7.3, 7.5 problem set number 5. And so we're supposed to use back substitution. And since we already have z equals to 4, we do y plus 2, plugging in 4 for where z is. 2 times 4 is equal to 6. We get y plus 8 is equal to 6, and y is equal to -2. So now we plug it all back in, so we get 2x minus -2 plus 5 times 4 for z is equal to 24. So we get 2x plus 2 plus 20 is equal to 24. So now we get 2x is equal to 2, and x is equal to 1. So now the ordered triple would be 1, comma, negative 2, comma, 4. And that's our answer. Okay, the next problem I missed was 7.6 problem set number 19. And so we have our matrices, and what we want to do is figure out what equation we can use to get from this to this. So for this one, we would do negative 2 row 1 plus row 2, because we're trying to find this right here. And so negative 2 times 1 plus 2 would equal to 0, so that's where we get this. This is this. If we do negative 2 times 4, that's negative 8. Negative 8 plus 10 is 2. So that's 2 right there. Negative 2 times 3 is negative 6. So that's negative 6. Plus 5 is negative 1. So that's where we get that. Okay, the next problem I missed was from the 7.6 problem set as well, but it's number 63. And so we have this setup. And so what we're going to do first, we're going to get into row echelon form. So we're going to go, row 1 plus row 3. So that now becomes x plus 2y minus 3z equals negative 28. We get 4y plus 2z is equal to 0. And now we cancel out the x's, so there's no more x. We get 3y because we add them together. And we get negative 4z because we add them together. And we get equals negative 33. So what we want to do now is we want to do 2 times row 2 plus row 3. So the first row stays the same. The second row stays the same. Now the third row now becomes, so we now get 11y, and then the z's cancel out so we don't put anything there, is equal to negative 33, because 2 times 0 is 0, then you just add it to negative 33. So now that we have that, we have, so y, so we have 11y is equal to negative 33. So now when we plug it back in, we plug all the numbers back in, we get y is equal to negative 3, z is equal to 6, and x is equal to negative 24. So our ordered triple would be negative 24, negative 3, and 6. And that's our answer.